Bob Raida, HEBI COO, will tell us about HEBI Robotics. HEBI was founded by my colleague, Professor Howie Choset in the School of Computer Science, who you may have seen recently on The Tonight Show with his snake robot crawling up the leg of Jimmy Fallon. Anybody see that? Nice. HEBI has participated in many of our programs as a Project Olympus Probe, as an NSF I-Core team, and in our Innovation Fellows program. So Bob Raida earned his undergraduate degree in computer science from the University of Pittsburgh and his MBA from Tedworth Business School. Prior to joining HEBI Robotics, Bob spent many years in the Pittsburgh startup community and was the co-founder of TrueCommerce, a software company that he helped grow to become a leading provider of business-to-business e-commerce solutions. So please welcome Bob Raida.
Thank you, Lenore. Hello, everybody. As Lenore mentioned, my name is Bob Raida with HEBI Robotics, and we produce Lego-like robotic building blocks. It's a platform of hardware and software that makes it easy to create custom robots quickly. And we think this is important because we see the world of robotics exploding into new areas, new potential for automation, new types of robots, new applications. We want to help accelerate this development by lowering the barriers to creating world-class robots. The technology was initially developed at the Biorobotics Lab at Carnegie Mellon, where a lot of research is done with snake robots. Now, a snake robot is a series of actuators or joints that are linked together and synchronized to interact within the environment. They are sensitive to force, and they use this force sensitivity to navigate through obstacles in the environment. But as you can well imagine, building snake robots and fixing snake robots is hard. And so researchers in the lab develop modular tools to make themselves more efficient. I said, wrong button. So what you see here is the initial modular unit that was used to make snake robots. I'll call it the snake module. So you can see the snake module up there, and you can see a snake robot created with the snake modules. But a wonderful thing happens when you enable brilliant people with cool new tools. They get creative, and so it didn't take long before the snake modules found their way into different types of robots, for example, the hexapod. And the arm that is feeding David Rawlinson his lunch, Dave's one of the co-founders at HEBI Robotics. And you may think Dave's at risk allowing a fork-wielding robotic arm to feed him his macaroni, but it's really safe, because the snake modules inherited that sensitivity to force that's so important to the snake robot. The arm knows how much force it can apply so that it doesn't hurt Dave or put the fork through the table. HEBI Robotics has picked up the development of this technology, and the latest iteration is this module that I have with me here today. It has retained all of the technical goodness of the original snake module, but it's been redesigned into a different form factor. It's been redesigned to be more robust, more capable, more powerful, easier to produce so that it's more cost effective. And you can create all sorts of different types of robots with the XSeries. Again, I'll mention that it's sensitive to force, so it's safe. It comes in various variants, ranging in less torquey, more higher speed variants to more torquey, lower speed variants, because not every joint of your robot needs to be the same. And a really important part of the platform is the software. So the API software that HEBI has developed enables the user to control the system at a system level, but also to control the system at a joint level and gain individual joint feedback and data logging. So what we've really done is taking care of a lot of the hairy math, the heavy lifting, the technical details that go into creating a robot, so that the roboticist, the creator, can focus on the more creative aspects of building a robot, the more interesting aspects of building a robot. And when that happens, all sorts of new applications and ideas come to light. We started selling this platform about a year ago, and the initial objective was to get it in the hands of end users. One of the challenges we face when dealing with a very broadly capable platform is identifying the right problems to solve. And so we said, let's get into the hands of users and see where they go with it. So we started working with universities, R&D organizations, and a handful of select industrial partners to get the modules into real use. Over the course of the past year, we've developed what I consider to be meaningful traction in the academic market. We've got a couple dozen different universities scattered around the world using our product, and that has given us excellent feedback that enables us to iterate and improve the technology, but it's also very inspiring for us to see the different types of projects that they're used in. As an example, here in Silicon Valley, NASA Ames uses the XSeries platform in their next generation prototype of their Super Ball bot project. So the XSeries platform is helping NASA research new ways to explore other planets. Another one of our customers integrated their vision system with our platform to create a bolt-on self-driving car kit. Bolts onto an existing car and makes it self-driving. So this is important to us, this research, and seeing how our customers are using the modules. Our company tagline, and indeed our company purpose, is accelerating the future of robotics. If you look at a research project that involves robotics or hardware, the bottleneck is the hardware. One of the things they say at the lab is when you touch hardware, as soon as you touch hardware, you're adding 2 years to your thesis. So if we can reduce that bottleneck by an order of magnitude and eliminate all the tinkering with homebrewed systems and enable those researchers to create their systems in days or weeks rather than months or years, then that changes a lot of equations in research, and it does accelerate. So again, we love the academic environment, we love our university customers, but we do have our eye on industry. Our long-term vision is to enable the industrial end user with that same kind of capability. And there are a variety of different applications where this may come into play in industry. I'll focus briefly on one segment here, and that is collaborative robots. So a collaborative robot in an industrial automation context is a robot that is safe to be used by, near, around people. So a traditional industrial robot needs to be caged. It needs to be separated by a fence because it could hurt somebody. Now, when you enable that robot to work alongside the human on the factory floor or on the production line, helping each other collaborate, you open up a whole new world of automation potential. And so naturally, that segment's getting a lot of attention in the robotics world right now. We look at the entrance into this space, and they all look like scaled-down industrial robots. Look as if they're designed based on decades of expectations of working with traditional industrial robots. And we want to change the way people think about what a robot really is. So perhaps your industrial application needs 1 degree of freedom. You don't need an arm. This is your robot right here. Or perhaps you need 2 or 3 degrees of freedom. You can do that with the HEBI platform as well. Or perhaps you need 10 degrees of freedom that are not physically connected, but they're synchronized with one another to perform a task. That's something that you can also achieve with the HEBI platform. So we think it can be a game changer in that context and many others as well. And no presentation is complete without mentioning that one of the strengths at HEBI is the team. So Professor Chosit at CMU has done a great job of establishing a world-class team of engineers. I am very pleased to be able to work with them each day and very thankful for it. And I invite you to check out our website. It's hebirobotics.com. And also, I want to note that we have a YouTube channel with a variety of demo systems showing off what we can do with the platform and what some of our customers are doing also. So please check that out. Also, it's YouTube/HEBI Robotics. Thank you.
Now I'd like to welcome Tom Lutz. Tom, where are you? Who is Chief Executive Officer and founder of Robotics. Tom has over 17 years of experience in autonomous robotics, working with Carnegie Mellon and in industry. Tom has developed autonomous systems to compete in the International Intelligent Ground Vehicle Competition and the DARPA Ground Challenge. Tom has a PhD in robotics and a bachelor's in aerospace engineering. Welcome, Tom.
So yeah, thank you so much to Dave and Lenore and Craig and everyone at the Center for Entrepreneurship at CMU. We are absolutely honored to be a part of this and to be bringing the great work that we're doing in Pittsburgh in robotics to the rest of the world. So my name is Tom Lutz. I'm the founder and CEO of Robotics. Our company does warehousing and manufacturing automation with robots. So I'd like to introduce you to Swift. Swift is the world's first industrial mobile piece-picking robot. This is Swift working at our first customer site in Rochester, New York, Rochester Drug Cooperative. The robot is picking goods at a rate of about 100 to 150 items an hour for distribution to mom and pop pharmacies around the Northeast. So the whole idea here is we have robots that are able to navigate around a warehouse to find items using computer vision. IM Robotics has developed the computer vision technology that allows them to navigate and see items. And so we can have our robots aggregate goods in the facility to bring those goods over to pack workers, pack and ship workers, so that people don't have to do the unproductive walking and material handling. The robots do that for them. And this can save a business upwards of 50% of their operational budget. And so there's a significant cost savings in being able to drive the economics of using robots and automation to aggregate goods in the warehouse. So what the robot does is basically just uses its cameras on board to navigate around. We have a map of where all the items are and a memory of what they all look like. The robot grabs them and picks them. All of this is driven by our software. So our software is called Swift Link. This is the software that connects the warehouse management system up to a network of Swift robots that will operate at our customer site. So this is everything that the customer needs to set up, command, control, configure, track the robots, and monitor their performance and make sure that they're all working as expected. Of course, things aren't perfect in the warehouse. When anything goes wrong, a person with a mobile device will get a notification through SwiftLink that says, hey, the robot's having some trouble finding an item, or something's out of stock, or what would you like to do? Would you like to wait? Would you like to continue? And those are the kind of options that we offer as part of this SwiftLink software. We also have other applications that we're working on beyond the simple piece-picking applications. So if anything is too small or too big for the robot to grab directly, then we can put those items in a box, and then the robots can go retrieve those boxes. Warehouse workers walk up to 60 to 90% of their time, and all of that time is paid for by our customers. So anything you can do to eliminate that unproductive travel time is very convenient. Of course, this is very similar to what Amazon does with their acquisition of Kiva Systems in 2012 for $750 million. But Kiva Systems just brings over a whole shelf of product. And what we're doing with Swift here is just retrieving the individual goods or the bin that has the specific product that you need. That's the difference. We also have a new stealth application in manufacturing. The customer here is the largest manufacturer in the world in their particular market, and they bring a customer lifetime value to our company in the range of $20 to $50 million. So we have an initial contract with them this year to start to develop the software. It's a $650,000 contract. Over the next 4 years, we have about $8 to $10 million budgeted to go to IM Robotics for installing a set of robots for their particular application. So the key question here is, why robots? What's the difference from classic automation? Because everyone's wanted to save money in business for the past 1,000 years. Why is it robots now? And this is the reason. They're out of labor, believe it or not. So if you do the math at a macroeconomic level, Americans spend 40 billion hours a year picking and shopping for consumer goods. To drive all that via e-commerce would take over 20 million full-time jobs the way that they currently do warehousing in the e-commerce industry. And that is absolutely more people than we have in the entire US unemployment pool. So we've been told by major executives that they can't find and keep enough people in this job. So we believe that robots that can work alongside people and work in the warehouse in this kind of manner that's interchangeable with manual labor is absolutely the way to sustain the baseline growth of e-commerce and the growth of manufacturing in the United States. A little bit about our business model. So we essentially sell robots as a service, and what that means is that we lease our robots for about $50,000 a year to our customers, and that includes all the support and maintenance and software upgrades that they need to continue to sustain their robots and grow their business. We're a little bit unique in the way we do this in that we use a financing partner, so that IM Robotics doesn't have to fund these expensive robots if we get a large order to scale. So our financing partner is AmeriCorp Financial. They finance medical equipment to the healthcare industry. And they got involved in this market through their work at Aethon, which is another Pittsburgh robotics company that does hospital robots that drive and move goods around hospitals. So they see this as a growth area for financing this kind of equipment, and allows our customers to scale faster without having a significant capital expense on purchasing robots. They can pay for them monthly and get a faster return on investment. So of course, all this is enabled by our team. Vlad and myself come from NREC, which is Carnegie Mellon's National Robotics Engineering Center. It's where a lot of the robotics commercialization work, a lot of the early driverless cars work that was done for the DARPA Urban Challenge, the DARPA Robotics Challenge. Some of you may have seen our chimp robot and so forth. That was all from CMU. And that was all from the National Robotics Engineering Center, which we were a part of. John Cameron is an expert in machine vision and perception. I worked with him at Harris Corporation doing classified robotics. Steve Brown comes from Philips Respironics and has a strong background in robotics and automation and in manufacturing. And Andrew Wells is our newly minted MBA from Pitt. Yes, we do work with Pitt people from time to time at CMU. So he's helping us with sales and marketing, and he's doing a great job. So our next steps for our company is Series A financing. We're going after at least $10 million this year to help us scale sales and marketing and manufacturing of our robots around our core team. Of course, we're looking at acquiring these new customers and new applications. We're scaling our deployments and refining our product in the process to make it better and better. So I hope you enjoyed meeting Swift today. Please get in touch with me if you're interested in learning more about IM Robotics. Very easy to reach, just tom@imrobotics.com. I'd love to talk with you more in detail about what we're doing. Again, I am Tom Lutz, and that's IM Robotics. Thank you very much.